We just finished page 1 of 4.5, and I just wanted to make sure everybody got this. So we picked a negative GCF because the leading term was negative, and we learned that you can't leave your leading term negative. You want your polynomial to have a positive leading coefficient. And we saw 5 was common, and we learned that you always pick the smallest exponent, so that's why we picked u to the first. And then when we divided those, we had positive 3u, 4 minus 1 cubed, positive 2, 3 minus 1u squared. These are all ones. And then we had negative 5, and the u's canceled there, so just 5. So that was our last answer. Okay. So now we're getting ready to factor out a binomial. So sometimes our GCF is not going to be just a single term. Sometimes it'll be 2 terms. Sometimes it'll be 3 terms. This section will all be 2 because it says binomial. So I look here and I go 5x and 2. They don't have anything in common, but they both have a 2x plus 3 common. So what I can do is take that out as my GCF. And because it is a binomial, it has to stay in parentheses. And if I divide this term by 2x plus 3, and this term by 2x plus 3, I see 1 there, 1 there. What do I have left? 5x minus 2. And again, that's 2 terms, so it does need to be in parentheses. So that's called factoring out a binomial, where on the last page we factored out a monomial, which means 1 term. So all of these are 1 term because there's no plus or minus signs. So that's factoring out a monomial. This is called factoring out a binomial. So whatever's common, take it out. So you guys want to try the next one? Because this one's kind of hard. So go ahead and try that one on your own. Just do the same thing we just did. And then stop back and check it. Okay, so on 8, we have nothing common in front. 5 and 9 just have a 1 common, M and N don't. But we do have a common binomial. So we pull that binomial out in front, and because it is 2 terms, it has to be in parentheses. Then we divide each term by the GCF that we just picked. And then that turns to 1, that turns to 1. So what do we have in the second parentheses? 5m plus 9n. Okay, so the next one's a little tricky. So it's tricky for 2 reasons, because there is something common out front, and our binomials aren't quite matching. In fact, they're what we call opposites. This is positive y, this is negative y. This is negative 3, that's positive 3. So I wrote a little note here that when you have opposites like that, you can take a negative out. Let me show you why. So 3 minus y, if I put it in the correct order, remember constants go last, it would be negative y and positive 3. Does everybody agree those two are the same thing? So negative y, positive 3, positive 3. This is writing it in the correct order. But then thinking back to what we just did on the last section, remember how we said the leading coefficient can never be negative? So then we take out negative 1, which is common, divide each of these by negative 1, and what do we get? Positive y minus 3. So we can replace this with that because they're the same thing. It's just switching the order of the terms without losing their signs and then factoring out a negative 1. If I distribute this, positive 3, negative y, I still get back to the original problem. So why would we do this? Because we want this to match that. And our terms aren't in the right order, so that tells us, oh, I need to turn the terms around. But when you turn the terms around, you see that leading coefficient's negative. So this is how I could rewrite it, 2x times y minus 3 plus 4c times negative 1 times y minus 3. And remember, I'm not doing anything illegal here because this still gives me that. I'm just making it look different. So it still gives me negative y. It still gives me positive 3 when I distribute it. So then going a step further, I get 2x, y minus 3. Positive 4c times negative 1 is negative 4c. And then we have our y minus 3. So now it looks like, quote unquote, a normal problem. Now it looks like the 2 in front of it has a common binomial. It also has something out in front that's common. Does everybody agree there's a 2 out front and there's a y minus 3? So for this one, 2 is common, y minus 3 is common. So I divide this by 2 and y minus 3. And I divide this one by the GCF 2 and y minus 3. And whatever I have left goes there. So 2 divided by 2, 1. Y minus 3 divided by y minus 3, 1. Y minus 3 divided by y minus 3, 1. And 2 goes into 2 once and into 4 twice. So what do I have left? X minus 2c for the second parenthesis. So that's a little bit tough for us right now. That would be more of an upper level class, maybe the next class. But I think I might have put 1 or 2 of those on your homework. So at least you have an example to follow through. So we have to change the order because they're not quite matching. So I put it in the correct order because y's go first, constants go last. Then I saw the negative, took it out. So then I took 3 minus y out and replaced it with what it's equal to. Then I multiplied those two. Then I found the GCF 2 and y minus 3, pulled it out in front. And then I divided each term by the GCF just like we did on these others. And I was left with x minus 2c. So, like I said, don't worry too much about that. If you get the other 2, you're good. But, sometimes we like to stretch your mind and make you go beyond your comfort zone. Okay, so the second type of factoring, so all the problems we've done previous, all 9 of them, have been called factor by taking out a GCF. So it's called GCF factoring. This next method is called grouping, factor by grouping, probably one of the most common ones you're going to see in this class. You will do grouping probably 300 times before summer's over. That's how much you're going to see it. A lot of times. So how do I know to do grouping? Well, in other classes, you're going to see you could do it with 4 terms, 6 terms, 8 terms. For our class, we just concentrate on 4 terms. So the minute you see 4 terms, that's the only method of factoring we have for 4 terms. The only one. So When I count 4 terms, I go, oh, this is a grouping problem. Grouping means we put the first 2 terms together and we put the last 2 terms together. Then I take the GCF out of those 2 terms. Then I take the GCF out of those 2. First, I look and see if there's anything common to all of them, which there's not, because 4 goes into all of those, but not into that. X is here, but there's no X there. There's no Y there. So that's what this is saying. First, see if there's a GCF for all 4. If there's not, then you do the first pair and the second pair and do GCFs from them separately. And then what we're going to have is a problem that looks like this, and we'll end up like that. So I know that sounds complicated, but it's actually a very easy method of factoring. So I know to do it whenever there's 4 terms. So I see 4 terms, nothing's common to all 4, so then I group them, the first pair, the second pair. So I pretend this doesn't even exist, and I look at these 2 and say, what's the GCF for those 2 terms? 5 goes into both of them. There's not a y common, but there is an x, and I take the smallest exponent, so x to the first. So then, just like before, I divide each of these by 5x and see what's left. So this would be 4, 2 minus 1, x to the first, minus, here the x's cancel, so I'd get 5 and a y. And this is key. This is huge right here. This term always goes down into the middle. So whatever the middle term is, it becomes the middle term here. And it's the sign of my GCF. So now I look at these 2 terms and say, what's common to these 2 terms? 6. There's no x common to both, but there is y. Take the smallest exponent, so 6y. So then I divide each of these by 6y and say, what's left for the parentheses? 24 divided by 6 is 4. The y's cancel, but I still have the x. Minus 30 divided by 6 is 5. 2 minus 1 is y to the first. And this is why I love this method. It's probably my favorite because there's a check right in the middle of it. If these don't match, you've done the problem wrong. Because our last step is to take out a common binomial. So if there's not a matching binomial, that means you made a mistake. It could mean the terms are in the wrong order, but usually it means you made a mistake. So these match. So remember how we did that up above? We took them out as a GCF. So I'm going to take 4x minus 5y out of each term. So divide by 4x minus 5y. Divide by 4x minus 5y. And then in the second parenthesis, write what's left. 5x plus 6y. And remember how I told you can always check these? So on these, you'll check by foiling. 20x squared, boom, there it is, outer, plus 24xy, there it is, minus 25xy, there it is, minus 30y squared, there it is. Remember how I said you can check every one of these? So I used to teach this in high school many years ago. I used to tell students, everybody should get 100 on this test. Everyone, because you can check every single problem. So anything that says factor can be checked either by distributing or in this case foiling and making sure it's up there. Okay, let's do one more and then you guys can practice one. So right away I go, oh, 4 terms. 4 terms mean grouping. So is there anything common all the way across? No. So take out a GCF here. It would be x squared. And I get x minus 5. Bring down the sign. Take out a GCF here and I get 4. x minus 5. Boom, there's my new GCF, so it's x minus 5.